Okay, so these are the examples for section 4.1 on radians and degrees. So example 1 says to determine the quadrant in which the angle lies. So since we're not real familiar with radians at this point, it's easier to go ahead and convert these angle measurements into degrees, then figure out which quadrant they would be in. So to do that, we're going to multiply the radians by 180 over pi. So when I multiply pi over 5 times 180 over pi, you're going to get 36 degrees. Okay, and then it's easier for me to recognize that 36 degrees is a positive angle going up from the positive x-axis. That's going to land in quadrant 1 of our coordinate plane. Same thing for B. We're going to multiply negative pi over 12 times 180 over pi, and you're going to get negative 15 degrees. This time, since this is a negative angle, we're going to go clockwise from the positive x-axis at 15 degrees, and that's going to land us in quadrant 4. So it's much easier to convert to degrees than go ahead and visualize what quadrant those should be in. Okay, so number 2 says to determine two coterminal angles, one positive and one negative. So coterminal angles, if you remember, add to equal 360 degrees, or in radians, they would add to equal 2 pi. So whatever measurement you're given the angles in, that's the measurement that you need to go ahead and figure out coterminal, or anything else. If you're given degrees, use degrees. If you're given radians, use radians. So if we start with A, we've got 7 pi over 6, and we want to find a positive and negative coterminal angle. So what we're going to do is we're going to add 2 pi to our angle, and then in a minute we'll come back and subtract 2 pi from our angle to find the other one. So in order to add these two, one is a fraction, so I need to have both in fractions have a common denominator so I can add them together. So 7 pi over 6 is going to say we're going to change 2 pi to something over 6. So to get a 6 on the bottom, I'm going to have to multiply 6 on top and bottom. So that's going to give me 12 pi over 6. So now I can just add straight across the numerators. 7 pi plus 12 pi is going to give me 19 pi over 6. So this angle is coterminal with 7 pi over 6. They start and end at the same spot. Okay, next we're going to take our angle and we're going to subtract 2 pi from it. So it's going to be the same process, just this time with the subtraction. So 7 pi over 6 minus 12 pi over 6, 7 pi minus 12 pi is going to give me negative 5 pi over 6. So these are two angles that are coterminal with 7 pi over 6. They have an initial and terminal rays that are the same. Okay, now with degrees, it's much easier. We know that coterminal angles add and subtract to equal 360. So we're going to take 45 and we're going to add 360 to it. So 45 plus 360 is going to be 405 degrees. Okay, then we're going to take 45 and subtract 360. So 45 minus 360 is going to give us negative 315 degrees. Both of these are coterminal with 45. They have an initial and terminal sides that are the same. Okay, now number 3, we're going to find the complement and supplement to each angle. So first, in geometry, we learned that the complement is when two angles add to equal 90 degrees. So in terms of radians, that's going to be pi over 2 radians. Okay, then if we're talking about the supplement means that they add to equal 180 degrees, or in terms of radians, that's going to be pi radians. So I'm going to set up a little equation here for A. We know that pi over 3 plus some other angle x has to equal pi over 2. So I'm going to subtract pi over 3 on both sides of the equation, so that our angle that we're solving for has to be pi over 2 minus pi over 3. Now we need to go ahead and change these to have a common denominator. Our common denominator is going to be 6. So if I want to change pi over 2 to something over 6, then I have to multiply by 3 on top and bottom. So that's going to be 3 pi over 6. Pi over 3 changed to something over 6, I have to multiply by 2 on top and bottom. So it's going to be 2 pi over 6. Okay, so now I can just subtract 3 pi minus 2 pi will be 1 pi over 6. So pi over 6 is complementary to pi over 3. Okay, so now we're going to do the supplement. So pi over 3 plus some other angle equals pi. This time we're going to subtract pi over 3 on both sides again. So this time our angle has to equal pi minus pi over 3. So common denominator, pi is going to change to something over 3. Well, that's going to be 3 pi over 3. So 3 pi over 3 minus pi over 3 is going to be 2 pi over 3. So 2 pi over 3 and pi over 3 are supplementary angles. They add to equal pi. Okay, next with the degrees, very easy. We're more comfortable with degrees, so it doesn't require as many steps. So 150 plus some angle has to equal 90. So I'm going to subtract 150 on both sides. So our angle has to equal negative 60 degrees to be the complement to 150 degrees. So for the supplement, we're going to do 150 plus something equals 180. So we're going to subtract 150 from 180, and that's going to give us 30 degrees is the supplementary angle. Okay, so complement adds to equal 90 degrees or pi over 2. Supplement adds to equal 180 degrees or pi. Okay, next number 4 says to determine the quadrant in which the angle lies and sketch. So what I like to do is draw a small coordinate plane and visualize how far 405 degrees is going to be. Well, I know that once around the circle is 360 degrees. So I'm going to have to go a little bit more to get 405. That's going to land me about there, because 360 plus 45 is going to equal 450 or 405 degrees. So this lands me in quadrant 1. So quadrant 1 is where angle 405 will land. So you just draw a little swirly around until you stop where you need to. Okay, same for 45 degrees. We're going to go ahead and start this time, and since it's a negative angle, we need to go down. We're going to go clockwise this time. So negative 45 degrees is going to be about there. So we draw our ray. So that is quadrant 4 for this angle. Okay? So just remember that positive angles go counterclockwise, negative angles go clockwise. Okay, number 5, we're going to convert from radians to degrees or degrees to radians, whatever we're given. So A, we're given 7 pi over 3. This is a radian measure, so we're going to convert to degrees, and we're going to multiply by 180 over pi. And I like to do this without a calculator as much as possible, just so I can simplify my fractions. So I notice that the pi's are going to cancel out. I know that 3 is going to go into 180 60 times. Then I can multiply 7 times 60. That should be pretty easy. That's going to be 420 degrees. So 7 pi over 3 is the same as 420 degrees. Same thing for B. We're going from degrees to radians this time. So we're going to multiply by pi over 180. So I'm going to reduce my fraction as much as possible. Those zeros are going to cancel. It's like doing 100 divided by 100. Then 24 over 18 I know can reduce to 4 over 3. So now I can just multiply everything and rewrite it as negative 4 pi over 3. So negative 240 degrees is the same as negative 4 pi over 3 radians. Okay, number 6 wants us to find the angle in radians. It gives us S, which is the arc length on a circle, is 32, and the radius of our circle is 7. So this is the formula S equals R theta that we looked at earlier. So we're just going to plug in what we know and solve for the angle in radians. So 32 has to equal 7 times theta. So to get theta by itself, we're just going to divide by 7 on both sides. So theta is equal to 32 over 7. And if I go ahead and divide that out, theta will be approximately 4.57 radians. Now this looks different from the radians we've looked at before. They had a pi in them. Well, this radian already has the pi multiplied out. It's something times pi equaled 4.57. So sometimes we'll see our radians in decimal format. Okay, number 7 wants us to find the length of an arc. It gives us that the radius of some circle is 15 feet and the angle that we're looking at is 180 degrees. We're going to use the same formula, S equals R theta. So our arc length is going to equal 15 times our angle measure. Now our angle measure has to be in radians for this to work. So we're going to change 180 to pi radians. We know that those are equivalent. So we're going to plug in pi instead of 180. And I'm going to go ahead and leave this as 15 pi since it looks nice and neat. Since this is the length of an arc, we need to include our measurement. So this is 15 pi feet. So the length around the circle, and this would be half of a circle, would be 15 pi. Okay, number 8 wants us to find the area of a sector. So the formula for area of a sector is 1/2 the radius squared times the angle measured in radians again. So we just plug in what we know. Area equals 1/2 of 4 squared times pi over 3 is our angle. So we're just going to go through and simplify. So 1/2 of 16 times pi over 3. I know that half of 16 is equal to 8 times pi over 3. And then I would just write this as 8 pi over 3. And since this is area, then we would write meters squared. So the area of the sector is 8 pi over 3 meters squared. Okay, your homework is going to be on page 290. You're going to do 8 through 24, jump to 34 through 66, and then jump to 80 through 92. And in each of these sections, you're going to be doing every other even.